In this video, I am going to solve these three problems taken from the book Principles of Physics 10th edition. The title of the chapter is Center of Mass and Linear Momentum, which is the ninth chapter in General Physics 1. Let's start the first question. The figure shows three particle system with masses m1 2 kg, m2 4 kg, and m3 8 kg. So you have to see this figure. In this figure, three masses are given. Am I right? So the masses of each is given in this question as m1 carries the value of 2 kg, m2 is 4 kg, and m3 is 8 kg. The scales on the axis are set by x of s, which is equal to 2 meter, and y of s, which is equal to 2 meter. That means you have to see the scale. So the particle is locating in the scale of x and y. So the limit of the scale here for x-axis is 2 meter, and the limit for the y-axis is 2 meter. Clear? That means here this is 1, this is 2. Clear? Likewise, x-axis, this is 1, this is 2. That means the scale for x and y both are exactly 2 meter. What are the x coordinates and the y coordinates of the system's center of mass? So what we are going to do, we are going to find the center of mass based on these three particles, which has the masses of m1, m2, and m3. Clear? So let's start. So this question has three subdivision. In the first part, we are going to find what is the x coordinate of the system. And the second question, we are going to find what is the y coordinate of the system center of mass. And after that, we are going to answer the third question, which is the theoretical information. Clear? So first, we are going to solve the part A and part B. So first of all, I'm going to write what is given in the question. So what is given in the question? The mass of the first particle is 2 kg, and mass of the second particle is 4 kg, and the mass of the third particle is 8 kg. Clear? Now we have to identify what is the coordinate, what is the location of these three masses, right? So now you have to use this scale. So for example, if you see the first mass, it is exactly sitting on the origin. Am I right? So that means the coordinates of m1, what is the location of this mass m1, which is exactly 0, 0. That means its x-axis value is 0, its y value is also 0, because I took this value exactly from the figure. Understand? And what is the location of the m2? You can see here the m2 x-axis value is exactly 2. You can see it's exactly 2, and y-axis value is 1. So the location for the second mass is 2, 1. And likewise, the third particle's location, the coordinate of the third particle's mass. So what is the third location? It's exactly in x-axis, it's exactly 1, and in y-axis, it's exactly 2. So 1, 2. So if you see, this one is, let's we take x1, y1, and this one is x2, y2, and the third one is x3, y3, right? Now we are directly going to apply this value in the formula, because we already know the center of mass formula. So first question, what is the first question formula? We are going to find the value of the x coordinates, x coordinate of the system. So for that, I'm going to use the center of mass formula. So the x coordinates center of mass, which is given by the rule m1 x1, because we have three particles, m2 x2 plus m3 x3 divided by the total masses. What is the total masses? m1 plus m2 plus m3. Clear? So now I'm going to substitute these values here. So one by one, I'm going to substitute the value here. So what is our mass of the first one? the mass of the first particle is 2 kilogram and its x1 value is exactly 0. So 2 multiplied by 0 plus, and the mass of the second particle is 4 kilogram and its x2 value is exactly 2. For the third one, the mass of the third particle is 8 kilogram and its x3 value here is 1 divided by m1, which is 2, plus m2, it's 4, plus m3, which is 8. That's it. Now I'm going to use my calculator. So let's see what is the answer for the first part. 2 multiplied by 0 is 0. So 0 plus 8 plus 8 divided by 2 plus 4 plus 8. So I got the answer as 1.14, 1.14, and all these are in meters. Am I right? So let's see the diagram. Everything is in meters. So I have to give the answer in terms of meters. So this is our x coordinate of the system. Which system? The combination of these three mass system. Clear? So this is my x center of mass. Likewise, I have to find the value of y center of mass. Clear? So y center of mass, which is given by the rule m1 y1 plus m2 y2 plus m3 y3 divided by m1 plus m2 plus m3. So now again I am going to substitute this value here. So we know the mass of the first particle. The mass of the first particle is 2, second one is 4, third one is 8. So 2, 4, 8, right? So 2 plus 4 plus 8 divided by 2 plus 4 plus 8. But I have to identify what is the y1, y2 and y3. What is y1 here? y1 is 0, y2 is 1 and y3 is 2. That means 0, 1 and 2. So 0 value for y1 and then 1 value for y2 and then 2 value for y3. Now I have to calculate what's the value. 0, 2 multiplied by 0 is 0 plus 4 plus 8 multiplied by 2 is 16, right? 16 divided by 2 plus 4 plus 8. So the answer is 1.43. What's the answer here? So I'll write 2, so 0 plus 4 plus 16 divided by, so 8 plus 2, 12, 10, 10 plus 4, 14. So the total answer here is 1.43 meter. So the y center of mass value is 1.43. So which is our B part. Clear? So now you can easily identify it. So you have to see the diagram here. So our x coordinate, x center of mass we got as 1.14 meter, and y center of mass value we got just before as 1.43. That means you have to see by x value here, which is 1.14. That means it will become here because we have to randomly we have to locate. So this is our 1.14 and this one is 1.4, which will become here, right? So when I just find the location of both intersecting point, I hope this is the value. Clear? So what is this value? 1.14 comma 1.43. Clear? So this is our center of mass for these three particles. Clear? Okay. Now we have to answer the third part, which is our theoretical part. So you have to read the question carefully. Okay. If M3 is gradually increased, you can see the size of the masses. M1 and M2 is smaller, but M3 is a little bit bigger. Am I right? So what they are given in the third part, suppose if M3 is gradually increased, that means if the third particle mass is increased, does the center of mass of the system shift towards M3 or away from M3? Or it will be remain stationary as it mentioned in the diagram, because we got 1.14 and 1.43 is the location. You know what they are exactly saying in the question. Suppose if M3 is gradually increasing, the center of mass will be coming towards this M3, or it is moving away from M3, or it will be exactly the same location. So what we studied in the theory, generally the center of mass of the system will always closer to the massive body. Am I right? So here they said the third body, the third mass is the massive. So generally, if you have the massive body, the center of mass will be always closer to that body. Clear? So we have to write the answer for the third part. We have to answer the third part as the center of mass will move towards the heavier mass. The center of mass will move towards the heavier mass. Clear? Heavier mass or massive body. Clear? So here they said M3 is increased. Am I right? So if M3 is increased, if M3 is increased, the center of mass will be moved towards M3. The center of mass will move towards M3. Clear? So if the M3 is increased, center of mass will be for sure, it will be moving closer to the M3 body. Clear? So this is the answer for the third part. Okay, now we have to answer the second question. Read the question line by line, word by word. Okay, what is given in the question? In Taekwondo, actually this is the martial art in Korea. Okay, so Taekwondo is the martial art. So they are always using their hands and the legs for fighting. So what is given in the question? In Taekwondo, a hand is slammed down onto a target at the speed of 30 meter per second. So they are using the hand for fighting. So how much speed he is moving? The person is moving 13 meter per second, and comes to a stop during the 5.5 millisecond collision. So now if you just see here, initially the body is moving with a 13 meter per second, and after that it comes to stop, and the time duration for this is exactly 5.5 millisecond. Now what we are going to do, we are going to answer these two questions. What is that? What is the answer for the impulse and average force? But still we have to continue the question. What they mentioned in the third line, assume that during the impact the hand is independent of the arm. So they are not using any arms, they are just using only the hand, and the mass of the hand is given as 0.7 kilogram. So let's write what is given in the question. What is the mass? The mass is given as 0.7 kilogram, and here the change in speed. Am I right? So that we are just taking only the magnitude, so that means the change in speed. So 13 and 0. Am I right? So what is the change in speed? The change in speed we can write as 13. Am I right? So 13 meter per second. And what is the time taken? The time duration is exactly 5.5 millisecond. What is the meaning for millisecond? Which is 10 to the power of minus 3 second. So we have the mass and the change in speed as well as the time. By using these three values, first of all, we are going to find the impulse. As we already studied the formula for the impulse. What is the formula for the impulse? The formula for the impulse. So impulse should be denoted, indicated by the letter J. So impulse J, which is equal to change in momentum, right? And also we have one more formula, impulse J, which is equal to average force multiplied by the time duration. So we have these two formulas for impulse. But I can't use this formula for this case. Why? Because there is no information about the average force. Time is there, and impulse is not given, and average force is also not given. So I can't use this formula for the first part. So again, we have two parts. So what I'm going to do, we have the another formula for the impulse. So impulse momentum theorem. What is impulse momentum theorem? J, which is equal to change in momentum, which is equal to delta P. So mass multiplied by change in speed. Clear? So I'm going to substitute the value. The mass value is 0.7 and the change in speed is 13 meter per second. So I'm going to multiply these two. 0.7 multiplied by 13. We got the answer as 9.1. So 9.1, what is the unit? The unit for the impulse is kilogram meter per second, right? So kilogram for the mass and for the speed is meter per second, or you can say, which is exactly Newton second, another unit, or Newton second also you can mention. Both are the unit for the impulse. Now we have to answer the second part. In the second part, we are going to find what is the average force on the hand from the target. So now we can easily find the average force. Why? Because you can see initially we don't have the value of the impulse, am I right? So for that purpose, and also the average force is not given, so we can't use this. But once you solve the first part, we can easily find the average force by using the second formula, am I right? What is our second formula for the impulse? The second formula for the impulse, which is J, which is equal to the average force multiplied by the time duration, am I right? The time of impact. So by that, if I rearrange this equation, the average force, which is equal to impulse divided by change in time. So I'm going to use this answer here. So I'm going to take this answer and I'm going to substitute here. And the time, the delta t, which is already given as 5.5 millisecond. Am I right? So I'm going to substitute the value here. So J value is 9.1 divided by 5.5 millisecond 10 to the power of minus 3. So once you solve, you will get the average force. So the average force, which is equal to 9.1 divided by 5.5 10 to the power of minus 3. So I got 1654.5. And what's the unit for the force? It's Newton. So if you want to write it in the power, 1.65 multiplied by 10 to the power of 3 Newton. So this is the answer for the second part. Clear? Okay, now we have to answer the third question. And the third question, you have to read very carefully because many informations are given in the third question. Let's read line by line very carefully. A 15 kilogram package is moving at a speed of 10 meter per second vertically upward along the y-axis. That means they are clearly mentioned which direction the object is moving. Am I right? The which direction the object have the speed. So you have 15 kilogram package. So better I'm going to write this mass is 15 kilogram. Understand? Okay. And what is the speed of this? Let's we take the speed of this 15 kilogram. So I'm going to mention as V naught, which is this V is not volume because this is the speed. Okay. So V naught is 10 meter per second, they clearly mention it is vertically upward direction of XY axis. So what is the vector notation? The unit vector notation for this. The unit vector notation for the Y axis is J cap. Clear? And then it explodes. Which one is explode? This 15 kilogram package is exploded. So once it exploded, it will be converted to three fragments, so three pieces. Okay, once it exploded, this 15 kilogram package is in the form of three fragments. So M1, M2, and M3. So I'm going to write M1 here. So what is the value of the M1? They clearly mentioned 2 kilogram, right? And this one has 2 kilogram, which is shot upward with the initial speed of 20 meter per second. Again, after it exploded, the first piece, that means the first fragment M1 has 2 kilogram, which is exploded again in the vertically upward direction. That means the unit vector notation for this is exactly J cap. So that means the speed of the first fragment B1, which is 20 meter per second, J cap, right? And a 3 kilogram fragment, it shot in the positive direction of the horizontal x-axis with an initial speed of 5 meter per second. So what is the mass of the second piece? The second fragment has the mass of 3 kilogram. And what is the speed of the second object? The speed of the second object is exactly 5 meter per second. But which direction it is moving? It is moving in the positive direction of the x-axis. So the unit vector notation for this speed is I cap. Clear? Now, what is the third piece? The third piece mass, if you want, because that information is not given here. Am I right? So what is the total mass? The total mass is 50. And this mass is broken into three fragments. The first fragment has 2 kilogram. The second fragment has 3 kilogram. So what is the mass of the third pieces? What should be the mass, right? So you have to read the question very carefully, brother. Okay, so 2 is the first piece and 3 is the second piece. So what is the remaining? So here we have 5. So that means the third fragment has the value of 10 kilogram, right? Right or not? Because the total mass of this object is 15 and this object is broken into three pieces. The first pieces has 2 kilogram, the second pieces has 3 kilogram. That means totally 5 kilograms. So what is remaining? The remaining is 10 kilogram, and that is nothing but the mass of the third object. Clear? Now by using this, we are going to find what is the speed of the third fragment. So we are going to find the value of V3. Clear? So that is our first part. And in the second part, we are going to find the total kinetic energy. What is the change in total kinetic energy we are going to find? Understand? So we are going to find the total kinetic energy we are going to find. Clear? Okay, now I'm going to write the rule. What is the rule? Law of conservation of linear momentum. Law of conservation of linear momentum. What is the law of conservation of linear momentum? Initial momentum, which is equal to the final momentum. Am I right? So law of conservation of linear momentum, which is momentum initial, which is equal to momentum final. So what is our initial momentum for this part? So that means this part, which is equal to this part. Clear? So that means the left hand side is caps M and V naught. This is the formula for the momentum. So that means before collision, sorry, before explosion and after explosion. So how I am going to frame the equation for the law of conservation of momentum? It's very easy. Initial, that means before explosion. So M multiplied by V naught, which is equal to after explosion. M1 multiplied by V1 plus m2 multiplied by v2 plus m3 multiplied by v3. So now we have all the values. Am I right? Am I right or not? So let's we substitute this value one by one. What is the biggest mass? The total before explosion, the mass of the object is 15. Am I right? So 15 kilogram multiplied by what is the speed? The speed of the initial object is 10 meter per second, right? But it is in the j cap, the y-axis. So 15 multiplied by 10 j cap, and the unit for the mass is kilogram, and the unit for this 10 is meter per second, which is equal to the mass of the first object, the first body after the explosion is 2 kilogram, its speed is 20, but it is in j cap. Am I right? So 2 multiplied by 20. 2 kilogram multiplied by 20 meter per second j cap. Clear? Plus m2. What is the value of m2? The value of m2 is 3 kilogram. What is the speed of the m2? 5 meter per second I cap. So 3 multiplied by 5. So 3 is the mass and its speed is 5 meter per second I cap. So 5 I have right here, okay, I cap, plus the mass of the third object is 10 kilogram, right? So 10 kilogram multiplied by V3, because we don't know what is the value of this V3, we are going to find that answer. So now better we multiply these two. 15 multiplied by 10 is 150 j cap. Clear? And what's the unit? Kilogram meter per second, which is equal to 2 multiplied by 20 is 40 kilogram meter per second j cap, plus 3 multiplied by 5 is 15 kilogram meter per second I cap, plus 10 V3 kilogram meter per second, because we don't know, we are going to find this value of this V3. So what I'm going to do, I'm going to separate this V3 as well as the rest of the term. Am I right? So what you'll get, you can add or subtract this j cap, because what we studied in chapter number 3, if you want to add or subtract, you have to only deal with I cap with I cap, j cap with j cap, and k cap with k cap. Am I right? But here in this equation we have 2 j cap. Am I right? So what I'm going to do, I'm going to separate this term 10 v3, which is equal to, I'm going to move this 40 as well as 15 to the left hand side. By that this equation becomes 150 kilogram meter per second j cap. It's already in the left hand side. Now I am going to move this 40 to the left hand side. By that it becomes minus 40 kilogram meter per second j cap, and I am going to move this 15 to the left hand side, minus 15 kilogram meter per second I cap. Clear? Okay. I'm going to subtract these two. Why? Because both are j cap. So 150 minus 40, but both are j cap, so I can deal with this. Am I right? So 150 minus 40 is exactly 110 kilogram meter per second j cap, and this one is minus 15, right? Clear? I think this one is it exactly 15? Let's we check one more time. Yeah, it's 15 kilogram meter per second I cap, and left hand side we have 10 v3. Therefore v3, which is equal to, this 10 will come to the right hand side of the denominator. By that 110 divided by 10 kilogram meter per second j cap, minus 15 divided by 10 kilogram meter per second j cap. Sorry, I cap. This is not j cap. Clear? This is I cap. So if you divide this 110 with 10 means it is exactly 11 kilogram meter per second j cap. This one is exactly 1.5 kilogram meter per second I cap. Left hand side we have V3. So how we can find the speed? By taking the magnitude. So we already studied the formula for the magnitude in chapter number 3. So the x component square plus y component square, after that you take the square root, so you will get the answer. Am I right? So what is the rule? For finding the magnitude of the third speed, I am going to take the square root of the x component square. What is the x component square here? Minus 1.5 the whole square plus the y component square, which is 11 square. So let's see what is the answer. So V3, which is equal to, so I'm going to work out by using my calculator, square root of minus 1.5 square plus 11 square. So I got the answer as 11.1 meter per second. Clear? So this is the answer for the first part. So the speed of the third particle we found as 11.10 meter per second. Now we have one more question, which is nothing but what is the change in kinetic energy? That means total. So initial, which is equal to final. So we already studied the concept of the kinetic energy with a momentum. Am I right? So we studied two collisions. Am I right or not? It's like a collision. Am I right? So initial, that means what is that? The collision before and after we studied. Am I right? So elastic collision and inelastic collision. In elastic collision, the kinetic energy as well as the momentum is conserved. In inelastic collision, the kinetic energy is not conserved, but the momentum is conserved. Am I right? So now what I'm going to do, I'm going to use the same equation and I'm going to modify that equation for the kinetic energy. So let's work out with the same type. B part, I'm going to apply the kinetic energy for that. What is the equation we used in the first part? M V naught, which is equal to M1 V1 plus M2 V2 plus M3 V3. Am I right? So now you can convert this in terms of kinetic energy. So what is that? Half caps M V naught square, which is equal to half M1 V1 square plus half M2 V2 square plus half M3 V3 square. Now you have all the values. Am I right? That means the initial kinetic energy is in the left hand side. Am I right? So in the left hand side we have the initial kinetic energy. The right hand side is the final kinetic energy of these three masses. So now suppose if you got the answer both left hand side and the right hand side same value, the collision here represent is the elastic collision, because we studied in the theory, in elastic collision the kinetic energy is conserved. The initial kinetic energy must be equal to the final kinetic energy. Suppose if the left hand side values and the right hand side values are different, it will exactly says the collision here is inelastic collision. Clear? So now we are going to find what is the value we are going to get from the left hand side, what is the value in the right hand side. Clear? Okay, let's substitute the value. Half the capital value of this mass, the total mass is 15 multiplied by what is the V? 10. Am I right? So 10 square, which is equal to half. The first piece of the mass is 2 kilogram. Am I right? We studied. Am I right? So 2 multiplied by what is the speed of the first object? The speed of the first object here is 20. So 20. Second one is 3, 5. That means 3 kilograms, 5. Third one is 10. And this V speed we found here. Am I right? So I'm going to substitute all the values here. So the first mass has the speed of 20 square plus half the second mass value is 3 multiplied by 5 square, and the third one is half. The third mass is 10 multiplied by, what is the speed? Just before we found the answer of the third speed, 11.10, right? So 11.10 whole square. So now please calculate in the left hand side and the right hand side of the equation. So half multiplied by 15 multiplied by 10 square. So I got 750. Left hand side is 750 joules. Right hand side, let's we calculate for the first one. Half multiplied by 2 multiplied by 20 square. So I got 400 here, plus likewise this side. The second object mass is 3 and its speed is 5 square. Am I right? 37.5 plus, and the third one 10 multiplied by 11.10 square, we got 616.05. So I'm going to add all the values in the right hand side. 616.01 plus 37.5 plus 400. 1053.55 joules in the right hand side. That means this value is the final kinetic energy, and this 750 joules is the initial kinetic energy, right? So what is the total kinetic energy? The total kinetic energy here is the change, am I right? So final kinetic energy minus initial kinetic energy, which is 1053.55 minus 750. What's the answer? 1053.55 minus 750. I got the answer as 303.55 joules. Clear? So this is the answer for the second part. Understand? So please, when you substitute the value and calculate that, you should be very careful. If you missed a single value, then the final answer will be different. And also here in the first part, please calculate the speed of the third particle. It's very, very important. And while you calculate the left hand side and the right hand side, and for arrangement of the equation, subtracting the same term, and you should be very, very careful while you do all these things. If you made a single small mistake, that will affect everything, because here the first part has the connection with the second part. If you made a mistake in the first part, it will exactly affect the second part answer also. Clear? So please work out very carefully. Understand? That's it. Thank you.